So far, whenever we wanted to check if a prompt was any good, we ran it once, read the response, and decided it looked fine. That's okay for poking around, but it's a bad way to ship anything real, especially at scale. Users will throw inputs at your prompt that you never thought to try, and to tell how it holds up, just saying it looked fine when I tried it is not gonna cut it. And the stakes are real money. In a production system, even a small tweak to a prompt can swing cost and quality significantly. So before you approve a change like that, you need more than a gut feeling. We need an objective, quantifiable way to measure it. The fix is to stop testing by hand and start testing by dataset instead. Feed the prompt a batch of representative inputs that simulate real-life traffic, grade every response, and get an actual number back. That number is what lets you compare one prompt against another instead of just guessing which one feels better. Before we can grade anything though, we need something to test against. That's what this video is about. We are building our dataset. Prompt evaluation in this course comes in two pieces. This video covers the first one, generating a dataset of test cases. In the next video, we'll take this dataset, run it through a prompt, and grade the results. This same generate then grade pattern comes back later in the course, applied to prompt engineering techniques. That's the most natural case to reach for it, and probably the most common, but not the only one. The same approach works for evaluating any part of an LLM pipeline, like comparing different models on cost and performance, for example. The lesson code is built around a simple scenario. We are testing a prompt that writes AWS-flavored Python, JSON or regex, so we ask Claude to invent 3 sample tasks from those domains. Things like write a regex that matches an S3 bucket name. Each one comes with a solution criteria field, describing what a correct answer looks like, which is what the grader will lean on later. The official course generates this dataset with the same prefill and stop sequence trick we already picked apart in the structured output video, where it relies on fake assistant turn, closing backticks as a stop sequence, and then parses a plain string. We are not going to repeat that here. We already established it's a dead end on current models, so this lesson skips straight to using chatstructured, the same helper we used in the fourth lesson. One user message, one schema, one typed array in the response, and no fake conversation business. Let's look closely at the task schema imported from shared types.ts. And then compare it to the prompt text. It explicitly asks for solution criteria, but it never mentions a format field. And yet every task in our output will have one, correctly set to Python, JSON or regex. That's the schema doing the work the prompt text never had to do. Because format is required with a fixed set of allowed values, chatstructured fills it in regardless of whether we spelled it out in plain English. This is the same constraint decoding we covered in the previous video. The schema isn't a suggestion that the model would try to follow. It's a hard boundary on what tokens are legal at each step. Whatever the schema marks as required shows up regardless of whether the prompt asks for it. Same story with the count. The prompt says generate 3 objects in English, and the schema separately pins min items and max items to 3. The English is just being polite, the schema is what actually guarantees 3 items. The official course points out that dataset generation doesn't need your most capable model. A lighter, faster one does fine, since the task is just inventing sample data, not solving anything hard. There is nothing to switch in our ported code. The model in settings.ts is already set to Claude Haiku 4.5. That's been our default model for the whole course, so we are well aligned with the official course's advice. Write output lives in shared.ts. It creates the output folder if it doesn't exist, then writes into the file a JSON string if you hand it an object, or the raw text if you give it a string. It's the same job Python does with open and JSON.dump, just wrapped into one call for convenience. The commented out console.log result can print the raw object with our generated tasks, in case you want to monitor the full shape of the response. npm run dev, run this lesson, and check o5dataset.json in the output folder. You should see 3 tasks, each with a task description, a format of Python, JSON or regex, and a solution criteria string. Leave the file there for now. We are going to use it as the input in the next lesson. So, the dataset is done. Let's halve the job. Next video takes these 3 tasks, run them through an actual prompt, and grades what comes back. That's the part that turns looks fine into an objective score. See you there.